Hi, thanks for watching my video on finding the rational roots of a polynomial function. Today we're going to use just one example. We're going to find all the rational roots of the polynomial function f of x equals 2x cubed minus 7x squared plus 8x minus 3. What I want to consider first is the end behavior of the function. Now you want to notice that the degree is 3, so the degree is odd, and the leading coefficient is positive. So what do you think that the end behavior of this function would look like? I hope that you thought about this. It looks something like this, where your graph is approaching infinity, f of x approaches infinity as x approaches infinity, and f of x approaches negative infinity as x approaches infinity, negative infinity. So as your x's are going further and further to the right, which is a positive direction for your x's, your y's are going higher and higher, which is a positive direction for your y's. If you're going left with your x's, that's a negative direction, and going down is a negative direction for my y. So f of x approaches negative infinity as x approaches infinity. So I would need to figure out how many times is the graph going to cross the x-axis, or how many x-intercepts does the graph have. And another way to say the same thing is how many roots or how many zeros does the graph have. Now remember that my graph looks like this. So depending on where the x-axis is, that'll tell me how many x-intercepts that I have. The x-axis could be up here, which would give me 1 root, or maybe the x-axis is here. That would give me 1 root as well. It could be that the x-axis is right there, and you see how this would give me 2 roots? Or maybe the x-axis is here. That would also give me 2 roots. Or maybe the x-axis is right here. So the maximum amount of roots that I could have would be 1, 2, 3. So I will either have 1 root, I'll have 2 roots, or I'll have 3 roots. Those are the only options that I have. So I want to list all the possible rational roots. Now remember, rational means fractions. So this doesn't mean that these are my only real roots. I could have other real roots, but I'm looking for the rational roots, the fractional roots, the numbers that can be written as fractions. What I want to think about first is p. P is all the different ways that I can find the factors of -3, of my constant term. And that would include positive and -1 and also positive and -3. Q is a factor of the leading coefficient. So Q could be plus or minus 1, or it could be plus or minus 2. But the possible rational roots are always going to be P over Q. So if I'm trying to figure out what P over Q could possibly be, I need to consider plus and minus 1 over 1, and also -1, plus or minus 1 over positive or -2. I need to also consider positive and -3 over both of these, actually all 4 of these numbers as well. So this is my set of numbers that could possibly work. So what I'm going to do to help me with this, rather than try to put in every single one of those factors, I want to graph this first. I'm going to put this in my y equals, and I get this graph. And notice when I did the graph, I used my x minimum to be -4 and my x maximum to be +4, and that's because my smallest possible rational root was -3 and my largest possible rational root was 3. And right in here is where it's crossing the x-axis. That's kind of hard to read. So what I'm going to do is adjust my window a little bit. I know I don't have any negative numbers for roots, for possible rational roots. They're all right in here. It looks like they're between 0 and 2. That's where my rational roots are. So I'm going to zoom in on that a little bit. And it's still a little bit hard to read, but you can kind of tell right here it looks like it's going up, touching, it's coming down, and then it's going through. So it looks to me like it's touching the x-axis right here, and it's crossing the axis right there. And if I'm reading this right, this looks like it's about 1. That was 2, so maybe 1.5, which would be the same thing as 3/2. So that's what I'm going to try. I'm going to try 1, and I'm going to try 3/2 to see which of these could possibly be a root. I don't need to do the other numbers for P over Q because they weren't even possibilities when I looked at my graph. So I'm going to use synthetic substitution. And I'm going to try 1 first, because that will be easier than the fraction. So I want to bring the 2 down. 2 times 1 is 2, plus a -7 is -5. -5 times 1 is -5. 8 minus 5 is 3. 3 times 1 is 3, and that does give me 0. This is my remainder. If I were to divide this polynomial by the factor x minus 1, remember, if 1 is a root, then x minus 1 is going to be the factor. So right now, I have f of x is equal to this polynomial, which is also equal to x minus 1 times (2x squared minus 5x plus 3). And I got these numbers, the 2, the -5, and the 3 from this. When this is my remainder, these numbers give me the coefficients of the x squared term and the x term, and also of the constant if I were to divide this by long division. So now I need to just look at this. This is my new function. This is my 2x squared minus 5x plus 3, and I'm going to try 3/2 and see if 3/2 would also be a function. I don't need to try it with this whole polynomial now, because I know that I already divided the x minus 1 out of this to give me this trinomial. So bring down a 2. 2 times 3/2 is 3, and then add -2 times this would give me -3, and my remainder is 0. So what I know now is that I have x minus 1 times x minus 3/2 times, right down here, this is my constant, and this is my linear term now, 2x plus 2. So my rational roots come from each of these 3 factors. I need to set each of those factors equal to 0, and I would have rational roots of 1, 3/2. Sorry, I should have had a negative sign right here. And another one. But I don't need to write those 2 1s twice. So it's 1 and 3/2 are my only roots.